Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the Spring 2021 semester. This is the CCNP ENCOR version 8 course from the Cisco Networking Academy curriculum, and in this video we're going to be taking a look at Packet Tracer Activity 15.2.1, where we're going to configure and verify Ntp. And in this video, we're going to go over the client modes with Ntp, specifically the static client mode as well as the broadcast client mode. We're going to talk about the server mode and the symmetric active mode, which is also referred to as peering. And then we're going to go ahead and dive in and talk about Stratum, and we're going to look at some of the Ntp servers available on the internet. So let's go ahead and dive in and take a look first at the activity. So here's our activity. We have router 1 and router 2 going through a switch to the Ntp server. You can see we have all of our publicly routable IP addresses here. These are all 209.165, so everything's a /24. And so let's dive in. It says server N1 is already configured as the Ntp server for this topology. Verify its configuration. So to do that, we would simply open up the server GUI and then take a look at the services. Now, over on the left-hand side here, you can see the tab Ntp, and you can see that Ntp is on. Now, authentication is disabled, and I believe we're going to be leaving that disabled. But as you can see, Ntp is on. Now, the first thing that you should do, and this is a common mistake that learners will make both personally and professionally, so in the course as well as in the real world when they're trying to configure an Ntp source, is they'll go to the internet, they'll look up some of the NIST servers or the Google Time servers, and they'll just plug in the IP address or the host name. Well, the first thing that you should do is verify that you can actually reach that Ntp server. And so here we'll go from user exec mode to privilege exec with the enable command. And I'm just going to privilege exec here to get ready for future tasks. And let's see, from R1, can I ping the 209.165.200.225? And we need to first check and make sure that we can reach that network time server, which is just node 1 or N1. And we do have connectivity. The ping should be successful, and it was. And let's repeat that from router 2 to make sure that we have connectivity. Let's say 209.165.200.225. Now, it's important to remember that Ntp, the network time protocol, uses UDP, right? Not TCP, it's using UDP. And it's using port 123 for both the source and the destination, right? So typically, like we just saw actually with BGP, where BGP was using TCP, the transmission control protocol, in order to make that neighbor relationship happen. And we saw a random high coming from the BGP speaker that was trying to initiate the BGP communication going to port 179. In fact, I already have a Wireshark packet capture here with an Ntp packet, and you can see we've got router 8 is set up as an Ntp server. Specifically, it's an Ntp master server, and it's doing broadcasting. And so it's broadcasting, and we'll take a look at the configuration for that. Very straightforward. Under the Fast Ethernet 00.10 interface, it is set up to broadcast its Ntp information. And you can see we get some information right out of the gate here. It would be using Ntp version 4, and it's a broadcast. And there is the destination IPv4 address that is broadcasting out to all IPv4 speakers, and anybody who's listening looking for Ntp would find some interesting information. And here you can see the user datagram protocol. The source port is 123, the destination port is 123. So it's not some random high source port going out to 123, right? Because again, this is broadcasting that, hey, I've got time information that I am sharing if you're interested in listening to this as an Ntp Broadcast Client, not a static client, but a broadcast client. And I'll show you the difference between the configurations. And then we've got the Ntp information here. And again, all kinds of information that we're going to be talking about as we scoot through this activity. But again, the key is it's Ntp version 4. And there is an Ntp version 3, which was the predecessor, but version 4 supports IPv6. And so that's something to keep in mind. And again, most current iOS versions are going to be Ntp version 4. This box is running 15.1 code, which is, quite old in terms of iOS code in the 15x branch, and it's still running Ntp version 4. And you can see we've got all kinds of reference information down here, delay, whatever else is going on with Ntp. And so that is what an Ntp packet that's being broadcast out onto an Ethernet multi-access segment would look like. All right, so now we're going to configure Ntp clients. And so it's actually, again, these activities are nice. They're going to walk us through, excuse me, what's going on. So let's go back to router 1, and the device can be configured to refer to an Ntp server to synchronize their clocks. And so we're going to be configuring this. Let's first say show Ntp status, and you can see that Ntp is not enabled. And then I'm going to say show clock, and we may get that ubiquitous Monday, March 1st, or I should say just that March 1st, 1993. You often see that date. And so that date is typically, if you pull the router or the switch out of the box and you flip it on and you say show clock, that is typically the value, excuse me, that you might see. And so how do we fix that? Well, let's go into global config, and it's very simple. We're going to say Ntp server. Now, I'm configuring router 1 as an Ntp static client. And by static, what I mean is I'm not listening for multiple possible servers that could be broadcasting information to me. I am hard coding in that this is the static Ntp server from which I want to receive Ntp information, therefore making me a static Ntp client. And so I would just simply say Ntp server 209.165.200.225. Now, let's see if we've got that option over here. So there's a key option. Now, if we were doing some sort of authentication, we would be putting the key value in here. What I'm looking for here, more importantly, is the prefer option, because typically you have more than one Ntp server from which you can configure an Ntp client to possibly receive information from. And so if I was to jump over here onto a real Cisco router, and we'll just jump onto router 2, and I'm going to use two make-believe, sorry about that, let's get into privilege exec and into global config. I'm going to use just two make-believe values here. So if I was to say Ntp server, 209.165.200.1. Now, if I do a question mark, you can see we've got all kinds of things going on over here. I can specify the Ntp version, right? And again, if I was to say version, do a question mark, you'll see we've got Ntp versions 1 through 4. If I was to put 4, that is the version that is the default. So watch what happens. And so then I can say prefer, right? So in other words, what I'm saying is use this Ntp server as the primary, and then if there's another one that I wanted to set up, just in case the 200.1 goes down, I want to have 200.2 on standby, right? Let's say do show run include Ntp server. Now, let me ask you, why is it that I said version 4, but version 4 doesn't show up here? Right, because it's the default version, right? This is the default version that router 2, which is running the latest iOS that you can get for a 3945E 15.7 in the mainline branch. And so again, this is the default version 4, which is why we don't see it there. Now, the prefer statement, again, that just simply says, hey, if I've got 2 NTP servers configured, or if I've got 3 NTP servers configured, or if I've got 4 NTP servers configured, I'm going to prefer the first one. And again, for me to switch it to say, if I wanted to prefer 3, I would just go back to where I configured 3 and say prefer, right? Let's say one explodes on the internet or they take it down, it's gone forever, and you need to change things up. Now I'm preferring 3. And what I would do is if one went away, I would go ahead and say no, and then NTP server, and drop this out of here. And then we would see that it's gone, and now I'm preferring 3. Right? And so that's how you can change the NTP server that you're preferring. And so I was hoping that that would be here. It's not, but that's okay. And so again, this is an Ntp static client configuration. And I hit enter, and that's pretty much it, right? From a static client configuration where I'm not entering in multiple Ntp servers, I'm not doing any kind of authentication. That's very straightforward and simple. That's the configuration. So now it wants me to go ahead and let's go ahead and say write mem. Let's verify the NTP settings. So I'll say show clock. And as you can see, NTP does take some time to synchronize. On Cisco devices, the polling interval can be anywhere between 64 and 1,024 seconds. And that polling interval is not configurable. Right? So we may have to wait here a little bit, right? And again, we've got other configuration tasks we're going to work on right now, and then we'll circle back and we'll see that this is hopefully going to update for us. All right. So you can see right here, allow a few minutes for the clocks to be synchronized, and that is absolutely 100% the truth. So that was a static Ntp client configuration. Let's come back over here to router 2, and here's what we're going to do. We're going to go ahead and pull off the Ntp configuration, again, this make-believe configuration, so that I could demonstrate something to you. And we're going to remove all Ntp configuration because we've seen the static Ntp client configuration. Now let's take a look at an Ntp broadcast client configuration and how that gets done. Remember, on router 8, and let's come over here to router 8, this is going to be my Ntp master. If I say show run include Ntp, you can see the stratum I think we set to 4. Yeah, so Ntp master, and I set the stratum to 4. Now, interestingly enough, Cisco recommends that you typically start at 10. If I was to go into global config and say Ntp master, you can see the stratum levels range from 1 to 15. 1 being the most trustworthy, and 15 being the least trustworthy. And that's a way to think about it, right? Is that 1 is super, super accurate. And 15, it might not be so accurate. And so while we're talking about accuracy, right, let me go ahead and set this to 10. And again, I've seen this in a couple of books where they recommend you set it to something like 10 because I am not an atomic clock. I'm not a radio clock. This router here, router 8, and router 8 is not a GPS type clock time source. And so we want to set it to something. And again, it doesn't mean that it's going to allow it to go out of drift more or that it's not going to be used. It's just simply saying, hey, listen, I'm a time source, but you know what? I'm not a cesium atomic clock type source, right? And so if we talk about sources here for a second, here's a list of the time servers that are available from NIST, right? Now, again, remember, one of the things you want to check is, can I even reach these time servers? So if I was configuring time and I wanted to say, hey, can I ping time.nist.gov? Can I even reach that? And you can see here, it resolves to this IP address, but for whatever reason, off of my iMac here, I can't reach that IP. But what about another IP like utcnist2.colorado.edu? All right, well, it's a NIST server, and I can reach it. So maybe I would use this. Again, if I put a time source in there and I say, hey, prefer time.nist.gov, and I can't reach it, well, then we're going to run into some issues with that time source actually working for me. So again, always make sure that you can reach it. And if you're going through a firewall where they're only allowing certain things out, make sure that UDP port 123 for NTP is a service that's being allowed outbound. And so if you were to just Google NIST time services, Google has clocks. You can see Facebook's got some NTP clocks, and then here's Google, time.google.com. So let's see if I wanted to use that, time.google, oops, sorry, let me ping time.google.com, and great, I can reach that. So you know what? Maybe I use that as my time source. Now, this is a server, and there's probably an NTP master command, right, or a stratum level, and if I was to use that, time.google.com, what we should see is when I said show NTP associations or show Ntp status, what I should see is the stratum number that I have, and then I would subtract 1 from that, and I can get the stratum number of the actual NTP server that I'm referencing. So back to NIST, you can see that this is back in 2014. I'm sure this thing's still around, but NIST has this atomic, I think it's called a cesium atomic clock or something like that. But you can see NIST F2 would neither gain nor lose a second in 300 million years. And yeah, here it is right down here. It's both clocks use a fountain of cesium atoms to determine the exact length of a second. So you're probably going to reach the point of diminishing returns, right? If you're trying to set your network up and really all you're concerned about is, hey, I just want to make sure my time is accurate, to a few seconds, because if I've got some logs I want to take a look at to do troubleshooting, that's probably good. Again, this is to the extreme here, but hey, if you can reference some of the NIST servers that are maybe referencing this NIST F2 as their time source, you're probably going to be pretty accurate in terms of the time that you have. And so again, this is sort of where a lot of the internet, the time on the internet, is referencing a lot of these sort of atomic clocks to keep things accurate. All right, well, let's step back over here. Let's go back to router 2, and actually, I'm sorry, back to router 8. And this is the configuration information that I need to be a broadcast server, right? To set myself up as an Ntp broadcast server, right? I simply come under the interface, the Ethernet interface, fast Ethernet 010, do show run internet interface, fast Ethernet 00.10. And you can see that I've got the Ntp broadcast command here. All right, well, if I'm broadcasting out Ntp information and router 2 is on that same segment, can I ping 10.0.0.8? And I can use that broadcast time to my advantage and simply get under interface fast Ethernet. This is actually going to be gigabit here. Gigabit Ethernet 00.10, and we say do show run int gig 00.10. You can see we have no NTP config here, just my ncap.1q statement. But now I want to participate in leveraging. I don't want to be a static NTP client. I'm going to be an Ntp broadcast client. And so if I say NTP and do a question mark, you could see I could disable NTP. If there was a multi-class client information being sent out, I could get that. But I want to be an Ntp broadcast client. And you can see, again, I can give the Ntp version. If there is a key, I could use that. Or I could just simply say Ntp broadcast client. And that is what's going to be required. So now let's say do show NTP associations. And again, it'll typically take a little while. You can see I don't have any NTP associations here. What about do show NTP status. And you can see that the clock is unsynchronized, and when it's unsynchronized, the stratum will be 16. Think of that as unreachable. Like, I have no reference clock right now, right? I don't have anything set up at all. And so let's run it again, and we may need to circle back here. It's unsynchronized, so we'll circle back. And again, sometimes it does take a few minutes for things to work itself out. So are the clocks synchronized? And take a look at that. Now the clock is synchronized here on router 1. So let's say show Ntp status. And it's great to have sort of some other things to talk about while we're waiting for Ntp to sort itself out. So you can see that the clock is synchronized, stratum 2, and the reference source is the server PT, right, in 1. Now, if I was to say show Ntp associations, you can see that it shows me that the system is peered with that time source right there. We know that that's the N1 time server, and we can see that it was configured, right, with the tilde, and that is my current system peer time clock. And you can see the stratum level of that source is 1, which is why my stratum level is +1. So in other words, 2. If the stratum level of the source was 4, my stratum level would show 5. If the source was 9, my stratum level would show 10. And again, you can see we've got some polling information here, the delay, the offset, the dispersion of the time. And again, what are we looking? I'm looking for some other information here. And again, that's pretty much it. And so now when we say show clock, you can see that my clock has changed. If I come back to the real Cisco router over here, and let's end out of here, and let's say show clock, let's see what it thinks. And so that looks pretty good. Let's rerun that show Ntp status command. And we're still unsynchronized, but the clock should be synchronizing here shortly. Oh, I'm sorry, it is. I looked at the clock unsynchronized. And so you can see the stratum is 11, because what did we set the stratum level to on our reference? On router 8, we set it to 10. And so my stratum is now 11. And so let's say show Ntp associations. And so you can see that we set up an Ntp server in broadcast mode and an Ntp Broadcast Client, and we now have that information. All right, so let's go ahead and roll back to the activity, and we are on router 2. It says execute the same command on router 2. And so let's come to router 2, and we should see show clock detail is what I believe they're looking for. You can see we're using the hardware calendar, and you can see that that is also out of sync. And if I could remember the command to synchronize the hardware calendar versus the software calendar, if I can think of it, I'll run it. But again, you can see that we are not synchronized up here. If I say show Ntp status, we should not be running Ntp. We haven't configured it. Show Ntp associations. We don't have any associations. And so let's go ahead and make that happen. So we'll say Ntp server 209.165.200.225. And again, the activity is 100%. That's great. But let's make sure that this is going to work. And let's also make sure that we talk about a few other things. So show Ntp status. So we can see the clock still shows unsynchronized, even though associations show that we're associated. Let me roll back because there's something important here. You'll notice there's no asterisk here right now, just the tilde saying that, hey, it's configured, right? It's configured, but you're not fully peering with it yet. On router 1, we had that asterisk, meaning, yeah, we are synchronized. If we go out here to router 2, and we ran that associations, oh, I'm sorry, we ran it, it's right down here. You can see that it shows, yeah, I'm getting my time, but we don't have the configured, so there's no static configuration. If I run the command again, see, we don't see the tilde. There is no static configuration. We're just a broadcast client we're not configured to specifically listen to that server. We are configured to listen to whoever or whomever may be broadcasting NTP information out there. So we've seen the NTP master configuration on router 8. We configured that to be a stratum 10. We've seen the Ntp static client configuration in the packet tracer activity. We've seen the Ntp broadcast client configuration here on router 2. The final thing we're going to talk about, and let me see if they even offer it here, because the conversation would make sense here, right? Because we've got these two routers that are on theoretically the same LAN segment. Again, we could ping and check, or can we get onto the switch here? So let's jump onto the switch, and let's say the quickest way would probably be to say do show VLAN brief, and show VLAN brief. And yeah, it looks like everything is going to be in VLAN 1. So we can assume that these two routers have reachability to each other. Well, what happens if for whatever reason, router 1 loses its connectivity to this server PTN1? What if there was a firewall on this far side over here for the NTP server, and someone made a bogus change and they block router 1's IP from accessing the time server, right? Could happen, right? Could happen. Or something else could happen where router 1, for whatever reason, just loses access to the NTP server. Well, this is where Ntp symmetric active mode comes into play. And it's also referred to, sometimes you'll hear it as Ntp Peer Mode, or just simply peering with NTP, right? And what that means is we can configure router 1 and router 2 to sort of use each other as peers to get time information in the event that the primary NTP server becomes unreachable. And so let's see if we can do that. My guess is we're not going to have that. And I don't see the Ntp peer command. Let me get into global config over here. And the way that I would do that, and we should, there it is, Ntp. And as you can see, right, on the real iOS, you've got many more options here. So I would say Ntp peer, and I would put router, if this is, let's assume this is router 2 in the packet tracer activity, I would put in the IP address 209.165. We'll just say 200.1. That's router 1. And then on router 1, I would put Ntp peer 209.165.200.2 for router 2. And if either router 1 or router 2 lose their authoritative NTP source, they would use each other to keep synchronized. In other words, they would use each other as backups in the hope that if router 2 loses reachability, in the hope that router 1 still can reach the master, and then I'll just use router 1 for my time. And if router 1 lost connectivity to the NTP server, it would hope that router 2 still has connectivity and then would just use router 2. And that's referred to symmetric active mode, Ntp symmetric active mode, which is just that Ntp peer command that you just saw. All right, well, we talked about a lot of NTP information here. The configuration without authentication is extremely straightforward, right? You can simply set yourself up as a static client and point out to a NIST server or a Google server or a Facebook time server out on the internet. Remember, always confirm that you can reach that server before you plug that in to your configuration. If you have devices behind you in your network that do not have reachability to the internet, you can set yourself up with as a client, right? And let me actually draw this up real quick, because here's what it would look like. You are a router here in your enterprise, and let's say that it comes into a firewall or a switch of some kind, and you've got some other routers out here, and these other routers can't reach the internet, but you connect out and you can get to the internet and you can reach the NIST time server out here on the internet. And let's just say that this is the NIST time server, NTS. So what you would do on your router 1, your edge router, is you would put the Ntp server command and reference the NIST time server. And then you can have static Ntp clients down here, right? You would set up the Ntp master command, and then these guys would have Ntp client, or I'm sorry, Ntp server commands that point to you, because they can't get to the internet, but they can reach you. Or you could make it even easier. You could go under the interface with that Ntp broadcast command. If, again, this is into a switch and these guys are all in the same subnet, and then Ntp client on these Ethernet interfaces under the interface, or Ntp broadcast client, so that you're listening for those broadcasted Ntp messages that we saw in the Wireshark packet capture. All right, well, that is really going to do it for this conversation on Ntp Packet Tracer Activity 15.2.1. Thank you so much for watching, and I hope to see you in the next video.